Hi, well, if you're watching this video, it means probably two things. You are looking for a way of creating an evasion behavior that works against multiple enemies and obstacles. And it also means that you are really scraping the bottom of the barrel in terms of YouTube videos regarding this subject. But ignoring that, I'll crack on. I also had trouble finding a script that would work. They all just seemed to run away from a single person and not avoid obstacles. So I thought I'd have a go at rolling my own. And this is the result of that. And here's my example, just to give you a bit of an overview of what's going on here. In the middle of this, I have a player. It's static, it's not being moved around, because that just means that I can move targets in and out of its awareness without having to chase it around a map while it moves around. The grey sphere around is the awareness radius for this player. So basically anything outside this grey sphere, it just doesn't care about, won't try and do any kind of evasion at all. The blue things are what will represent my enemies, and the green things are what will represent obstacles. When I say things, I of course mean cubes. That's their scientific name there. Let's get this running, see what happens. Okay, if we go to scene view so we can see the gizmos. You can see my enemies have got these red lines. This just represents their field of view. So my player, even if an enemy comes into his awareness view, the player will not care about it unless the enemy is able to see them, i.e. in its field of view. So if we move this little fella back here, as soon as the player is in the field of view of the enemy, it starts looking for an escape route. And the way it does that is, first of all, it just calculates the most direct route of evasion, which is typically straight away from a pursuer. It then casts 5 rays, and it looks to see if any of those hit an obstacle or have any other reason to make them undesirable. In this case, it doesn't, so we are plotting a sphere where our evasion waypoint would be. If this was attached to a NavMess agent, our NavMess agent would now be instructed to head to this point. So that's great. So what happens when we add another one? Again, if we move it in and it isn't facing our player or looking at our player, it does nothing at all. But if we rotate this one, thusly, we can see the player has now calculated a new evasion route. So again, it takes this center line, which is the most ideal route to escape on, then cast some rays about it, and it will then pick the ray or pick the destination that is furthest from all the appropriate enemies, so all the enemies that the player cares about. So again, that's our center ray in this instance. We're going to take another one, more the merrier, spin it around, make it look at our player and move it in. Oh, not rotate like that, that's not going to work. Drag it like this. There we go, we can now see it has evaluated it again. Now, the reason this moves when I move the target in and out is that these values are weighted. So the closer a pursuer is to the player, the greater the effect it has on the calculated evasion route. So because this one's very close, the best evasion route, ignoring the others, would be kind of straight over here. But because we've got some other ones pursuing it as well, it leans slightly more this way. If we actually bring this one in as well, you will see how that affects the position. It forces it back over this way. If we move it down here, then that effect is reduced. And obviously, once it's calculated that ideal position, it then casts these rays. So we can see here, this purple line is the ideal position in terms of evading it based on a weighted calculation. So then it casts the rays, but it actually picks the ray that's furthest away from all enemies. Otherwise, if it actually plotted it here, although it would be the best evasion route for this one, it kind of moves it closer to here. Kind of moves it closer to this enemy. So that's all great. What happens if we start sticking some obstacles in there? So, okay, let's chuck an obstacle there. All right, it's going to move over to this side because this ray is, the best ray is blocked. So let's block that one too. Okay, now move to this one because it's the furthest away from all the enemies. Let's block that one. Okay, it's now going to head this way. If it came down this way at all, it's just going to be heading towards all of these enemies. And if we block this one, okay, it's getting desperate now. It's come over this way because this enemy is the furthest away, so it's the lowest threat. So of the limited directions it's got, it's actually going to make us kind of run over here. And if we block this one as well, you can see it now just defaults back to all of the routes because they're blocked, and it then picks the location that's furthest away but outside of the collision. If I bring all of these in, there is a minimum escape distance. So if all of these raycasts are less than that minimum escape distance, it will force the player into panic mode, which means it just casts a lot more rays over a 360-degree arc just to look for any way out. And again, once it's got those rays, it will find the ones that haven't hit something and choose the one that's furthest away from the enemies. The reason it's flitting between this is because once it's found an evasion point in panic mode, it should move to it ordinarily if it had a NavMesh agent. But because it hasn't, it then turns off panic mode after finding this spot, which means it relocates here, which means it turns panic mode on, etc. So basically you've got a constant cycle. That wouldn't happen if this player had a NavMesh agent attached and it could move. It wouldn't bother re-evaluating its position until it got to here, at which point the enemies would move and the obstacles would no longer necessarily be in its path. It seems to work very well. I'm going to try on a dynamic environment now, where the enemies move around and the player wanders, and we'll see what happens. But so far it's looking good. I will attach a link to my GitHub page where I'm going to put this project up if anybody wants to have a look at it, steal the code, modify the code for their own use. I'm actually writing this to incorporate into a behavior tree action, which should make it a lot more flexible. But this is a really good starting point if you're looking to create a behavior for evasion against multiple targets and multiple obstacles. Thank you.